First of all, I would like to thanks everyone whoever just click on this video. You will be able to get a lot of information related to LLM, data engineering, data analysis, right? In this channel, as well as I will just try to teach you a complex topic in a very simplistic manner, so that everyone who is even non-technical will be able to understand at least not 100%, at least 70 to 90% of that, right? So in for this video we will try to understand the journey of LLM, right? From where we started and where we are standing right now with respect to advancements, right? So let's get started. I will quickly switch my screen. And yeah, so before starting to the topic of the journey of LLMs, right, we will just first understand what is LLM. What is the full form of LLM? The full form of LLM is the large language model. Why we call it large language model? Because large specifies that it is being trained on a large set of data, huge amount of data, and its parameter, right, which is being calculated during the training, is also very huge. It's in millions and billions, right, nowadays. And what do we mean by language model? Why we call it a language model? Because it is able to understand and generate the language, right? It is able to understand, generate the language, as well as it's able to generate the audio, video as well, right? So that's the main definition of the large language model. Any model which comes within this definition is a large language model. Any model which is outside of this definition is not a large language model. Example is BERT and robot. We will discuss about that. Now let's get started with the statistical models. Uh, during 2008, 2010, right? Before that also, right? We used to use the probability statistics math formulas, right? To do the analysis, to create a model, right? To understand the NLP, to predict the next word as well, right? Hence, even though that is not that much of efficient, not that much of high quality outputs got generated using the statistical and mathematical model, but yeah, those are being researched and being used in many applications. I can think of an application of statistical model is our old phones, right? When we used to type a message, it was auto correct was happening, auto suggestions were also there, right? That was using the statistical mathematical models. So based on the probability of occurrence of two or three words together, it was able to identify the next word. So this is the statistical models. But what's the drawbacks? The drawback is of the statistical model is it's only counting the words which is occurring together, or even counting the words and then trying to apply some statistics and mathematics to uh, predict the next word. But there is no context understanding within this model, statistical model, right? Because of that, it was not able to generate the best output. So to mitigate those, research were happening in the neural network field. So initial 2013 and 2016, we call it a pre-deep learning era. During that time, um, feed-forward neural network were also there. So in between statistical model and RNN and LSTM, there is feed-forward neural network were also there, right? So these network are nothing but uh, when we are sending or when we are ingesting our words inside a neural network in a forward direction, we call it feed forward neural network. And also we don't have any loop, any memory within the feed forward neural network, within the neural network, then we call a network is a feed forward neural network, right? We already know that when we backpropagate our error into the previous layers, right, it the initial weights get optimized so that it decrease the errors, right, which is generated in the output. So by using this feed forward and back propagation method, it was able to it was able to convert the initial vector which we have passed inside this network, um, and it was able to provide us a very good, very efficient vectors, right, which we call a word to vector. Right? These feed forward neural network were specifically useful in NLP's task or LLM task when we use the word to vec kind of concept or a network, right? Uh, but the drawback of the RNN, but the drawback of the feed forward neural network were they they also don't understand the context of a sentence, right? Those feed forward neural networks were not trained for sequencing kind of applications. When we want to generate any word, it's a kind of sequence model, right? If we if we don't have anything which can be take care of the sequence of a particular word or a context of a particular word, then we cannot ingest it inside that. So to mitigate that feed forward neural network issue, RNN came into picture, which is a recurring neural network. Within this network, there is a memory as well as looping happen with respect to time. So let's suppose we have 4 words in our sentence: word 1, 2, 3, 4. Word 1 will go inside the RNN cell first, and then word 2, then word 3, and then word 4. Training is happening sequentially, not parallelly, because when we ingest the first word inside the RNN cell of a neural network, it generates the hidden state as well. That is being feeded inside the second timestamp of second timestamp RNN cell, and which is also having the second word, right? So second word. Let me draw it, right. Let's say this is our unroll of RNN with respect to time t, and we have one word here, second word here, third word here, right? So we have the hidden state as well, which is going inside these cells. These are hidden state 1, hidden state 2, right, and so on, hidden state 3, as well as these cells are generating the outputs. So this is the RNN. When we unrolled this with respect to time, we will not go deeper inside that, but just for the sake of completeness or a better understanding, I was just explaining. Uh, so what are the drawbacks of this kind of neural network which has RNN cells, right? The main drawback is the training time. Because of its sequential ingestion of the word vector, it was able to train not that much quickly, right? It was taking a lot of time to train. When we already know that if our model is hard to train, takes a lot of time to train, that there is a cost associated with it, right? So that is a major drawback, and we also know that LLM, if we want to train, that needs a lot of data, lot of training, lot of costing. So just because of that, advancement was not happening. This was not disrupting the industry. Something was needed, right? So that we can at least minimize this drawback, right? But there is one more drawback of RNN, that is vanishing gradient. If we have a long sentence, let's say we have a sentence from word 1 till word 1000, for example, or a word 10,000, let's suppose. So during the backpropagation, our errors were not properly backpropagated till the initial layers, and uh, because of that, our vanishing gradient problem occurs, right? The error becomes zero, and it's not able to go in the initial layers. So this is also a major problem, and it is a hindrance in the training. of RNN, right? So to mitigate that, LSTM came into the picture. LSTM has gate concept. It has gates, input gates, and as well as the forget gate. So if let's suppose we have the vanishing gradient problem. If we have something, let's say, for when predicting the word number 100, from word number 2 till word number 99 is not that much important, right? Only word number 1 is important. If there is any way we can skip those word 2 till word 99 and pass the error directly to the word 1, in that way we will be able to reduce or eliminate that vanishing gradient problem. So the LSTM was doing that. It was skipping the words, it was forgetting the words which are not important, and then the whole back propagation was going into the initial words or the initial word of a sentence. So it was able to LSTM was able to resolve that, but it also is having the training time issue. It was also taking a lot of time to train, and associated cost was also high. So we need again something which we need to reduce the training time. In 2017, Transformer came into the picture. Research paper called "Attention is All You Need" came into the picture, which introduced transformers, which contains encoder and decoder parts. Encoder is being used to generate the final context of our input data, that is nothing but a vector matrix, and generate the output using the decoders regressively. Regressively means one by one. We are generating first word, taking that first word into the decoder again, and then predicting the next word. So this is within this architecture, as well as the main important part of this transformer architecture is the multi-headed self-attention thing or a concept, right? We will be discussing this deeply if you want, but yeah, just understand that because of this self-attention concept, we were able to train our model very fast, because we were able to ingest our data in a single go inside the transformer model, and parallel training were happening. And also the results which this research paper provided, right, very disrupting, right? It disrupted the whole industry, the corporate sector as well as other sector. And in the research, a lot of company came forward and then took this as a base architecture and then start experimenting. So after that, the BERT robot came into picture, GPT came into picture. So BERT and robot. So BERT one, the BERT is created by the Google. They use the same transformer in the as a base architecture. Robot is also used by the Facebook. Nowadays we call it a Meta. They also use the same architecture with some tweaks. GPT, again OpenAI was experimenting with GPT at that time, and it was using the the decoder concept of transformer, because encoder is just for understanding of the input, but the decoder part is just for the generation of the output, right, with related to the as per the input uh, embeddings, right? So now GPT was using again the same architecture. Now with the advancement within the LLM world, right? OpenAI were researching more on these kind of models, and then they came up with GPT 3.5, GPT 3.5 Turbo, GPT 4.0, GPT 5.0. 4.0 is multimodal kind of LLM, which can take text, which can take audio, video as well as an ingestion data, and then predict the output in a textual manner, as well as an image, as well as an audio video. So in GPT 5, they bring the concept of agentic AI workflows. So in that, uh, we have to provide a particular goal, and then automatically it will try to bifurcate that goal into multiple tasks, and each task will be assigned to a particular agent slash tools, and communication will be happening within these agents, and then each agent will do its task and then revert it back to the main agent. And as a final goal, the agentic workflow or a system will complete the task, right, to satisfy the final goal. So this is the agentic AI. We will go deeper inside that. So I am going a little bit fast because I just want to touch upon this topic, right, and then quickly do our hands dirty in the LLM world, right? But if you want, I will just discuss this transformer in the next videos. But for the sake of this video, I think that's it. But you can just go through this grid, right? It has whatever I have explained, it has all the information, and you can take it as a handy notebook, right? Now I think we can quickly see what we will be going to learn in the upcoming videos. We have a slider for that as well. If you see, we will be learning level by level, right? In the initial phases, we will be uh, creating our foundation, right? We will be learning about generative AI, we will be learning about LLMs, we will be learning about what is prompting, we will be learning about how we can use frontier models as an API programmatically, how can we can leverage the output from the API and then use it in the other agent. These kind of things we will be learning in the initial backbone of this course. We will be learn about tokenization, positional encoding, right? So after that, we will be learning about the prompt engineering, that is a part of the level 2 of our ladder journey. We will be talking about the guardrails, adversarial prompting defense, right? All these concepts we will be learning in deep. So in the level 3, the RAG also we will be learning. There are different kind of RAG vector databases, how to evaluate RAG, how to evaluate the LLMs, how we can just measure two LLMs, which one is better, right? What are the metrics we can leverage to understand which one is better. All these things we will be looking inside that level 3. We will be fine tuning our embedding models, right, as well for retrieval purpose. But yeah, after the level 3, we will go to the level 4, which contains LangChain tool, Llama index, right? We have a CrewAI. We will be learning about OpenAI tool integration with respect to the Anthropic tool use, right? Uh, so if you see, we have a lot of things to cover, right? I will not go through each one of this now, but yeah, at last, what we will do is we will be creating multiple projects. We will be able to use or create a AI. We will be able to use Docker serverless agents, right, to productionize our LLMs, as well as how to productionize or create a governance on top of prompting, how to cache our prompts, it to make our LLMs very fast in our whole enterprise architecture. So these kind of things we will be learning. But as of now, that's it from my end. I will see you in the next video. Thank you.